This is the blue whale, by raw mass, the heaviest animal ever to exist. At over 80 feet long and up to 200 tons, it sits right at the edge of what evolution can physically build before an animal's own weight collapses it. Or at least, that was the story, until scientists found this jawbone. It belonged to a creature called Ichthyotitan, and it very nearly stole the blue whale's crown. Strangely enough, it wasn't a whale at all. To understand how big this animal really was, we first need to agree on what big means. Most people picture length, but by that measure the blue whale already loses. Argentinosaurus, a long-necked dinosaur, stretched around 115 feet, but most of that was a slender neck and a whip-like tail, and it likely weighed somewhere between 70 and 100 tons, less than half the blue whale. The bootlace worm can reportedly reach 180 feet, but it weighs about as much as a wet sock. That's not gigantism, that's just a long piece of string. The blue whale earns the title because it's a dense, solid mass of muscle and blubber, up to 200 tons packed into one body. In 2016 and again in 2020, fossil hunters on a beach in Somerset, England, uncovered 2 fragments of an enormous jawbone. Scientists compared them to known giant ichthyosaurs and, in 2024, formally named the animal Ichthyotitan severnensis. Based on that scaling, researchers estimate its body length at somewhere between 20 and 26 meters, roughly 65 to 85 feet. The scientific paper stopped there. The describing team was careful not to publish an official weight, since mass estimates from a single bone are far shakier than length. But independent researchers, extrapolating from body shapes of close relatives like Shonisaurus, have floated rough weight estimates in the range of 80 to 120 tons for a typical adult. Genuinely massive, but still short of a blue whale's average of 100 to 150 tons. Here's the catch. We found exactly 2 jawbones. Blue whales, by comparison, have been measured by the thousands, because they're alive and swimming in plain sight today. Out of what would have been millions of Ichthyotitan individuals across its existence, the odds that the only 2 bones we happen to find were from the single largest animals of the species are close to 0, which hints that this may not have been an unusually large outlier at all, but closer to a typical adult. Long before Ichthyotitan had a name, scientists in Aust, England, had already found a separate, even older jawbone, so large that researchers hesitated for years to say anything definitive about it. Once Ichthyotitan was formally described, paleontologists revisited that older bone and proposed it likely belonged to the same species, or something very close to it. Using the same scaling method, this specimen, nicknamed the Aust Bone, points to a length north of 30 meters, though the study's own authors flagged that figure as, in their words, very speculative, since it rests on a single fragment and an imperfect comparison. If that estimate holds up even loosely, independent mass extrapolations have suggested a weight approaching 175 tons, closing in on, though probably still not exceeding, the largest blue whales ever recorded, which topped out around 200 tons. None of this is confirmed science. It's an evidence trail built from 3 bones total, pointing toward the strong possibility that Ichthyotitan's true maximum size, like a blue whale's, likely exceeded its average adult size by a wide margin. Whether it ever actually surpassed the blue whale remains genuinely unresolved. What makes this strange is that gigantism like this usually belongs to mammals. Whales are air-breathing, blubber-insulated animals that need dense, heavy bones just to counteract their own buoyancy and dive at all. Reptiles are typically built the opposite way, for speed and agility, not bulk. But Ichthyotitan was fully pelagic, roaming the open ocean far from shore. And at that scale, being big is efficient rather than wasteful. Physics rewards size out here. The larger the body, the less drag it experiences relative to its mass, the same principle that makes an enormous cargo ship more fuel efficient than a speedboat. Size may have also unlocked gigantothermy, where a body simply becomes too large for its own heat to escape quickly, letting it function like a living thermal battery in freezing Triassic waters. And underwater, gravity plays by different rules. On land, an animal's skeleton caps out around 100 tons before its own legs would snap. In water, buoyancy carries the weight instead, which is exactly why marine giants like the blue whale and Ichthyotitan could push past that ceiling, while the biggest land animals never did. Size alone means nothing without food, and the late Triassic Ocean was an absolute buffet, packed with giant cephalopods, large fish, and other marine reptiles. Just as important, there was no competition. No whales yet, no megalodons, no mosasaurs. Once Ichthyotitan crossed a certain size threshold, it had essentially no rivals, and evolution rewarded that with more size still. Then, around 201 million years ago, the Triassic period ended violently. Massive volcanic activity from what's known as the Central Atlantic Magmatic Province flooded the atmosphere with carbon dioxide, warming and acidifying the oceans. It didn't kill Ichthyotitan directly. It starved it by collapsing the food web it depended on. A 100-ton body needs an enormous number of calories every single day, and when the ecosystem crashed, the largest animals were the first to run out of options. Ichthyosaurs, as a broader group, survived into the Jurassic, but they shrank and changed shape, trading bulk for speed. The ocean wouldn't build another true titan for nearly 200 million years, not until whales returned to the sea and evolved to filter feed on krill. Everything here rests on 3 fossil fragments. Scientists estimate that under 0.01% of all animal life that has ever existed left a fossil behind, and we've only recovered a sliver of that sliver, like trying to reconstruct an entire library from 3 torn pages found in the trash. The fact we found these bones at all on an ordinary beach hints these giants may not have been vanishingly rare, which raises an uncomfortable question. Is 200 tons really the ceiling for life on Earth, or just the ceiling of what we've dug up so far? Somewhere, under a mile of rock, in a moment of peak ocean abundance we haven't found evidence of yet, something even larger may have lived and vanished without a trace. Ichthyotitan wasn't just a big animal, it was a one-time experiment, the only moment in Earth's history when evolution built a true 200-ton giant out of a reptile instead of a mammal. It's a title we're unlikely to see repeated. Between an ocean now ruled by orcas and one dominated by humans, the specific conditions that let a reptile break the rules of size are gone, and they probably aren't coming back. The blue whale rules an ocean that a reptile had already conquered, 200 million years before it ever existed.